Hi everyone, good afternoon. Today we will discuss about the DC generator problem. The first question is a 6-pole lap-wound DC generator has 600 conductors on its armature. The flux per pole is 0.02 Weber. Calculate the speed at which the generator must be run to generate 300 volt. The second question is what would be the speed if the generator were wave-wound? So this question is two types. The first question is asking for the speed at which the generator must run to generate 300 volt, and the second question is what would be the speed if the generator were wave-wound. So to solve the first question asking about the lap wound. So for lap wound, first of all, we have to note down the given data. Here the pole is equal to, it is 6 poles, P is equal to 6, conductor Z is equal to 600 and flux phi is equal to 0.02 Weber. For lap wound, we have to find out the generated EMF. Generated EMF formula is equal to P phi Zn by 60A. And it is asking about the speed here. So I take out the N, and N is equal to Ez into 60A by P phi Z. So now we have to put the values for the respective data. Ez is equal to 300 into 60 into, for it is Lapan is equal to 6 divided by 6 into 0.02 into 600. By solving this, we will get 1500. We can solve them easily. We will cancel this 00 and 00 here, and 6 10 just 60. Then we get 1500 rpm. For the second question, wave wound, it is asking about the speed if the generator were wave wound. So the second question for wave wound, N is equal to Ez into 60A divided by P phi Z. Ez is equal to 300 into 60 by 2. By solving this, we will get the 500 rpm. So what would be the speed if the generator were wave wound? For the wave wound, the generator speed will be 500 rpm. Let's go to the second question. The second question is calculate the EMF generator by a 4-pole wave-wound generator having 65 slots with 12 conductors per slot when driven at 1200 rpm. The flux per Weber is 0.02 Weber. So we have to calculate the easy generator EMF for a 4-pole wave-wound generator. It having 65 slots with 12 conductor. So we have to first note down the datas. P is equal to, it is a 4-pole, so P is equal to 4. Flux phi is equal to 0.02 Weber. Z, it is saying that it is having 65 slots with 12 conductor, so 65 into 12, that is equal to 780, and it is a wave wound, so A is equal to 2. N is equal to 1200 rpm. So we have to find the generated EMF. Generated EMF is equal to P phi Zn by 60A. So it is a 4-pole. So I have given all the data. 4 into 0.02, Z is equal to 780 and speed is equal to 1200 divided by 68, that is 60 into 2. So by solving all these, we will get 624 volts. We can easily solve this 60. We will get 20 here. Next, 2 2s are 4. Then when we will multiply all this, we will get 624 volt. So the calculated EMF generated by this generator is total 624 volt. The next question is a 100 kilowatt 240 volt shunt generator has a field resistance of 55 ohm and armature resistance is 0.067 ohm. Find the full load generated voltage. Okay, here I have drawn the diagram for the question. Here is the shunt field, it is the armature field, and this is the load. The voltage across the load is, that is 240 volt. Here the load current is coming to the load, here the armature current, and the shunt current is coming to the field. So first of all we have to write down the datas. The power for the generator is, that is 100 kilowatt, voltage is 240 volt, and the field resistance, the shunt field resistance is 55 ohm, and armature resistance is 0.067 ohm. So first of all we have to calculate the load current, that is IL. IL is equal to, as we know, the formula for the current is equal to power and power by V. The power by voltage, or P by V. So here the power is 100 kilowatt, that is 100 into 10 to the power 3 divided by voltage is 240 volt. By solving this we will get the 416.7 ampere. You can also use the calculator to solve these problems. Shunt current. Shunt current is ISH. ISH is equal to, we can easily find out them because we have the shunt field resistance, that is 55 ohm, and the formula of current is equal to V by R. So I am directly putting the voltage 240 volt divided by shunt field resistance, that is 55, which is equal to 4.36 ampere. The next is the armature current. So how we will get the armature current? The armature current is forming by combining the shunt current and the load current. So I is equal to ISH plus IL, that is 416.7 plus 4.36, which is equal to 421.1 ampere. So the armature current is 421.1 ampere. Now the generated EMF is V, the generator voltage, that is V plus IARA. So we have to find the generated EMF by adding these two factors, that is voltage and the armature current and resistance. So 240 volt plus 421.1 into 0.067, that is armature resistance. Then we will get the 268.2 volt. So the generated EMF for the shunt generator is 268.2 volt. Fourth and the last question is, a 30 kilowatt 300 volt DC shunt generator has a armature and field resistance of 0.05 ohm. The shunt field resistance, that is 0.05 ohm, and the armature resistance is 100 ohm respectively. Calculate the total power developed by the armature when it delivers full load output. I have also drawn the figure. Here is the shunt field, it is the armature field, and voltage across the load is, that is 300 volt. So like the previous question, first we have to find out the load current. It is in kilowatts, so IL is equal to, we know that is power by voltage, so 330 into 10 to the power 3 divided by 300, which is equal to 100 ampere. The load current is our 100 ampere. Next, the shunt current, we can put directly the voltage by current, V by R. So I is equal to V by R. The voltage is 300 volt and the resistance is 100. We get 3 ampere. Shunt current is 3 ampere. Now the armature current. Armature current is forming by combining the shunt current and the load current. We are adding them. 3 plus 10 is equal to 103 ampere. Armature current is our 103 ampere. Next is the generated EMF is equal to V plus IARA. So voltage is 300 plus armature current is 103 into armature resistance is 0.05 ohm. Then first we have to multiply these two things, then we will add with the 300, then we will get 305.15 volt. And it has asked about the total power developed by the armature when it delivers the full load output. The power developed by the armature, that is equal to the generated EMF into IA. We know the formula of power, that is the voltage into current, and here we have already found the generated EMF. So the power developed by armature will be is E, the generated EMF, into the armature current. So the generated EMF already we have, that is 305.15 volt, into the armature current, that is we got your 103 ampere. So we will multiply this, and after that we have to find out the power into a kilowatt, because it is already given in the question. So 305 into 103, it became 31.43 into 10 to the power 3. So the power developed by the armature is 31.43 kilowatt. Thank you.